So same problem as our previous one. Now our function involves a trigonometric element instead. Main difference. Okay, so let's do the same thing. We'll do it. We'll try and figure it out by hand, and then we will verify that using the computer. So let's see here. We need a derivative, and just using our basic rules, the derivative of x would be 1. Of cosine is negative sine of x. We want to find the critical points, so that's where either this is 0 or undefined. Will be defined at all real numbers for x. So really we're just solving this for 0. So when does 1 minus the sine of x equal 0? It's whenever the sine of x equals 1. And that happens at the angle pi over 2. Maybe you remember your unit circle. These points are probably the ones you want to remember the most. This was at unit because it's 1 unit radius, so that's at 1, 0. This is at 0, 1, negative 1, 0, and 0, negative 1. And we can tell what the sine of an angle is, but based on the x and y coordinates of that point here. So the sine of these, well, the y coordinate of these points tells us the sine of the angle determined by that. All right, so here we have a sine of 1, and that is at this 90-degree angle, if we, okay, or aka pi over 2. So that's what, okay, so we get x equals pi over 2. There's our critical point. Same idea, we're going to bop this on a line and test values on both sides. Now to the left of pi over 2, nice easy value is 0. The sine of 0 is 0. Well, actually, yeah, so then we get 1. That's positive. We could plug in some number just to the right of this. I don't know, what's another, maybe pi. So the sine of pi, easy to figure out, that's 0, right? So again, we'd have a positive value here. So we go from increasing to increasing. What? Well, it's not always the case that a critical value is a maximum or a minimum. It may be neither. So that's what we need our first derivative for. It helps us to understand whether or not this thing is a maximum, minimum, or neither. All right. Now, hopefully this bears out if we just look at a plot, or we can even go through and do everything. So let's define the function first. Now, the other difference that we have to be aware of here is because if we want to use the symbolic computing, then the cosine has to also be a symbolic thing. So we have to use SymPy to define the cosine. And now we can find the derivative of, as long as we make sure that x, I'm going to just make sure that x is a symbol. Oops, forgot my return statement. Sorry about that. Okay, and sure enough, right, we get 1 minus the sine of x. So I'll also define a function as the derivative here. Make sure to remember my return statement, and that's going to be 1 minus the sine of x. All right, and we'll use that to determine our equation and solve it. So I'll actually do both of these here. I'll call this EQ. X and 0, and then we want to solve the equation for x. And just like we found by hand, that's pi over 2. Okay, we print it, print it. over 2. So then we can just test values on both sides of that, and we can use the symbolic form here. We can, again, try it at 0. It's positive. And if we also try it at pi, it's also positive. So let's go ahead and verify this with a plot, that we don't have a maximum or a minimum value occurring there. And we'll just redefine to anticipate some numbers. So we'll use numpy now. And we want to look at this on, maybe we'll go from -2 to 2 again. Keep forgetting my return statements. Here we go. And sure enough, right? We should, maybe we can get this. I'm sorry, our function was the cosine. That was thinking the derivative here. But same sort of thing that we see, right? Instead of it being a maximum or a minimum, it just kind of flattens out and then turns back up. So it's neither a maximum or a minimum. We can even plot this, okay, if we wanted to. We could say that we're looking at pi over 2 and f of pi over 2. We'll make it a red dot. There it is. And that, again, is where we just see kind of flatten out and go up. So in these two examples, we see the different things that can happen at a critical point. We could either change from increasing to decreasing or decreasing to increasing, or do neither. If we do neither, it's not a maximum or a minimum value.